Hello everyone, welcome to EkEdu. So today's topic is aqueous electrolytes. Now, in the previous class we had discussed about the molten electrolytes. So today we are going to discuss about the aqueous electrolytes, right beta? So in case of aqueous electrolytes, what happens is we have NaCl in presence of water. Aqueous electrolytes means we have NaCl in presence of water. So now, and here, like we are taking the case, if we consider the ions, we have Na positive ions with us, we have Cl minus ions, we have H positive ions, and we have OH minus ions along with us, right beta? So here we are actually assuming that the NaCl, it's concentrated, right? Because in the previous video I had told you that we need to understand the factors, right? So we need to understand the factors also. So here we are taking concentrated NaCl. If in exam nothing is mentioned that then you have to assume that NaCl is concentrated, right? Now we know that NaCl, it gets dissociated into Na positive ions and Cl minus ion, and water, it gets dissociated into H plus ions and OH minus ions. So this is how it happens, Na positive, and now we have anode. Now we have anode, and we know that what happens at anode, oxidation takes place, and we know that at cathode, what happens? Cathode reduction takes place at cathode, right beta? So oxidation will take place at cathode. So we have, and we know that here in this case anode is positively charged. So what all ions will be present? We have Cl minus ion or OH minus ion, and cathode, we know that cathode is negatively charged. Yesterday also I told you to remember this with NCr. So it's negatively charged, therefore we have H positive and Na positive ion, right beta? Now see what happens is, like we have already discussed about the electrochemical series, right? So here, like the anode, we have either chlorine will, the Cl chloride ion will go, or hydroxide ion will go to anode, and here also either H plus ion or Na positive ion will go to the cathode. Now what happens here is that in this case, what happens actually, like we have to see the preferential discharge of ions. We have to see preferential discharge of ions. Right? We have to check the preferential discharge of ions. Right? So now, next we have, so what happens is, I've told you that in electrochemical series, we have already discussed the order of the SRP values, right? So here we have, like, it starts from lithium, then hydrogen, then copper, right? Then we have silver, right? Below silver we have chloride ion, hydroxide ion, Cl minus, OH minus, then we have NO3 minus, sulfate, and at the end we have fluoride ion, right? I'm writing it again, the order of the anions. I'm writing it so that you can use, you have to remember this order of the anions for right beta. So this is the order, right? Now what you have to do here is, see, if we, for anode, right, we know that oxidation takes place at cathode. What happens? Reduction. So for cathode, what happens? The reduction, so SRP value should be high, and here anode, oxidation takes place. So for oxidation, we know SRP value should be low. So now we have to choose, like chlorine and chloride and hydroxide. We have two options. For the oxidation, we have two options, chloride or hydroxide. Now check the SRP values. Whose SRP value is lower? Chloride. So here we are preference with the fluoride ion, right, over hydroxide ion. And here we have sodium ion. We know that sodium is electropositive in nature, and H plus ion. Excuse me, please. This is hydrogen, H plus ion, right? So we have to write it at anode. We know that. What happens at anode? This twice of Cl minus will give you chlorine gas, will release plus 2 electron, right? What happens at cathode? What happens, beta? This H plus ion will accept or gain 2 electrons to form hydrogen gas. So we have chlorine gas at anode and hydrogen gas at cathode, right? So the following observations can be made with the help of this is that the concentration of Na positive remains same throughout. The concentration of remains same. But if somebody asks you, tell me the concentration of Cl minus, it's decreasing. Cl minus is decreasing. The concentration of Cl minus is decreasing. And also of NaCl it is decreasing because chloride ion is decreasing. But the concentration of Na, it remains same throughout. Now let us talk about the concentration of hydrogen ions, hydronium ions, right? H plus ions. The concentration of H plus ions are decreasing. Therefore, we can say in this the pH is increasing, right? See, I'm telling you all this because sometimes in exam what happens is, like in some of the options, they give statements. So that is why I'm telling the Na positive concentration remains same, Cl negative, because it's with time, as the time passes, it's getting converted into chlorine gas, therefore it is decreasing. H plus ion concentration is also decreasing, due to which we can say pH of the solution is increasing, right beta? So this is how the reaction takes place. Now if we try to write the net reaction, it will be twice of Cl negative plus twice of H plus gives you Cl2 plus water. Twice of Cl minus plus twice of H plus gives us Cl2 plus H2 gas, right beta? And we also have Na positive and OH negative also, so we can also write Na positive, and because they are present in the solution, so they will give us, so we will also get twice of NaOH, right? And this is how we actually synthesize NaOH in industries by this process. So this is the industrial synthesization of NaOH, that is sodium hydroxide. I hope this much is clear to you, right? So now in the next case, here beta we have taken the case of concentrated NaCl, right, in water. Now next case is when we'll take the second case is when we'll discuss about the aqueous NaCl. Aqueous NaCl, like dilute NaCl. Second is beta dilute. This time we are going to take dilute NaCl in water. Yes. First case was concentrated NaCl in water. This time we are taking dilute NaCl in water. Dilute NaCl in water. Right, beta? If like platinum electrode, of course, if no electrode is mentioned, that it means that we are going to take the inert electrode, that is platinum. So here what happens again? This NaCl will get dissociated into Na plus ion and Cl minus ion, and similarly this water, it gets dissociated into H plus ions and OH minus ions. So this is how the reactions are going to take place. But this time we dilute NaCl in water, means this water is present in excess, or we can say large quantity. It's present in excess. That is why now we know that what happens at cathode reduction? Yes, what happens at cathode reduction? And cathode is negatively charged, so either H plus or Na positive, right? So what happens? We know that twice of H plus will accept 2 electron to give hydrogen gas, 1 mole of H2 gas, right? Or I can also write it as 4 of H plus 4 electrons will give us twice of hydrogen gas, right? This reaction is going to take place at cathode. Now, anode, we know that at anode the competition is between oxidation takes place, and we know that this anode it is negative, positively charged. So we have chloride ion or OH minus, that is hydroxide ion, right? We know that there is a competition between the what happens at anode. There is a competition is there, right, at anode. So what happens later? The competition is between chloride ion and hydroxide ion, and we know that since the water is present in excess, right, the SRP value, like for oxidation the SRP value should be less, right? So oxidation of Cl negative should take place, but in reality due to the excess of water, what happens? The oxidation of OH negative takes place. So what happens is OH negative electron plus OH. But can we write it like this? No. So how do we write? We write it as twice of OH minus. Twice of OH minus. We write it as 4 of OH minus gives us 4 electron plus twice of water plus oxygen gas. This is how we have to write it. 4 of OH plus 4 electrons gives us twice of H2 plus O2 gas. So the net reaction, if we write the net reaction, it will be like net reaction beta. It will be 4 of H plus 4 of OH minus will give us twice of H2 gas, right, plus twice of water plus oxygen gas. 2 moles of water plus oxygen gas, right beta? So now what happens here is, here the important thing which you have to remember is that we get hydrogen gas. Yes, we get oxygen gas, and we also get water. So at the end, we get 2 moles of hydrogen. Yes, 2 moles of hydrogen we are getting, and we are getting 2 moles of water, right? And here we are getting 1 mole of oxygen gas, right? At the end, we are getting 2 moles of hydrogen gas and 1 mole of oxygen gas and 2 mole of water, right? But so this is what we are getting. I can also write it as 4H plus first 4 OH means 4 moles of water. I can simply write it as 4 moles of water will give me 4 moles of water. 4H plus 4 OH plus gives you 4 moles of water, or simply 2 moles of water is giving me twice of hydrogen gas. Two moles of water gives me twice of hydrogen gas plus 1 mole of nitrogen gas. Yes, bachche. This is 1 mole of oxygen gas, right? This is nothing but this is the electrolysis of water. 2 moles of water gives us 2 moles of H2 gas plus 1 mole of oxygen gas. Now, if we take only 1 mole of water, So the ratio of hydrogen gas is to oxygen gas is 2:1. So if we take only 1 mole of water, we will be getting only hydrogen gas, 1 mole of hydrogen gas plus half mole of oxygen gas, because the ratio oxygen and the ratio between oxygen and hydrogen gas is 2:1. This is the ratio. Right, beta? I hope this much is clear to you. See, what you have to remember in this question is that instead of chlorine chloride ion getting oxidized, here the oxidation of OH negative hydroxide ion take place, and that will see how 4 OH minus gives us 4 electrons plus 2 water plus oxygen. So we are getting oxygen and water where at anode, and we are getting hydrogen gas at cathode, right? So basically what you have to remember here in this case is, see, the difference is that in case of concentrated HCl, right, we are getting chlorine gas and hydrogen gas, but in case of dilute NaCl, we are getting oxygen gas and hydrogen gas, right? That's it. Now the next case which we are going to study is a very important case, which is third case, where we are taking NaCl, concentrated NaCl in presence of H3, Hg, mercury as electrode. Now we have concentrated HCl, right? But check, concentrated HCl where with Hg electrode. We have Hg electrode. So suppose we have again here platinum. We are not taking platinum electrode, we are taking mercury electrode. So what happens? NaCl will get dissociated into Na positive plus Cl minus, and water, it gets dissociated into H plus and OH minus, right? So what happens at anode? What happens at anode? We have platinum, right? But here, what is this? What is going on here? Just a minute, check. We have Hg at Hg cathode. We are taking amalgam. We are taking amalgam. That is Hg as cathode. In the next case, I am teaching you about the active metal electrode, that is Ag, silver. Here we are taking amalgam, Hg amalgam as cathode, right? So here what happens here is anode. What happens? Simply C out of Cl minus and OH minus, because here the case of concentrated, we know that what happens, it's twice of Cl minus simply gives you Cl2 gas plus 2 electron. Very simple, right? We've done it earlier also, the very first case of today's video, right? Now next we have next let's talk about cathode, where cathode will amalgam, right? Hb is also present. So we have twice of sodium because we have amalgam electrode. So instead of H plus ion, we have sodium ion will participate and will get this. We'll get twice of sodium, and here this twice of sodium will react with amalgam to give sodium amalgam. We'll get sodium twice NaHg, will get sodium amalgam. I hope this is clear to you, right, beta? So basically, because sodium is highly soluble in amalgam, that is why we are getting sodium amalgam. And pH, if we talk about pH, in this case, pH has no effect, right? Because there is no change in the concentration of H plus ions. I hope this much is clear to you. Now the last case is we have aqueous NaCl. Either you can take aqueous or molten NaCl with Ag electron. This time molten NaCl with Ag means we are taking the case of active metal electrode with Ag electrodes. Aqueous or molten. Now what happens here is In this case, this is a very special case. What happens here is, see, we have like active metal, and anode we have active metal. So what happens? Either Cl minus, OH minus, or the oxidation of Ag will take place. And we know that the SRP value of Ag is low. So therefore the oxidation of Ag will take place, right? Ag gives us Ag plus electron, right? Now let us talk about cathode. What will happen at cathode? See here, what will happen at cathode is, this is a very special case which I am discussing today. Cathode, we know that reduction will take place either Na positive, so Na positive, H positive, and Ag positive. Here also the SRP value is maximum in case of Ag positive, right? Silver metal has the maximum SRP value, so Ag positive plus electron will give us Ag, right? So this is how. So means at anode also the oxidation of Ag is going to take place, and at cathode also the reduction of Ag positive is going to take place. So this is a very famous process, and it's used in electrorefining process, this reaction, right? Suppose what happens here is, like at cathode we have pure metal, and at anode we have impure metal. So what happens here is, so with the time the oxidation of Ag is going to take place, and it's getting converted into Ag plus electron, and the reduction of Ag plus is going to take place into Ag. So we can collect the pure metal on the cathode electrode.